I welcome all to this online session. Today we are going to start the second unit in dynamics of machines. So here we are going to see about the balancing of rotating mass and the reciprocating masses. So all the machines have many moving parts. So some machines have rotating motion and some have the reciprocating motion. So if these moving parts are not in the complete balance, then inertia forces are set up and it causes excessive noise, vibration, wear of the system. So now we are going to see what is meant by balancing. So the main objective of finding the balancing of rotating mass here is, so first we are going to explain the what is meant by balancing of mass, and then we are going to see the different types of balancing of rotating masses, and finally we are going to carry out the force analysis of balancing of the rotating mass. So now first we are going to see what is meant by balancing. So in a steam turbine or in any rotating part, there is a rotor, or we can say there is a shaft. So the rotary motion of the shaft is the supported by the some bearing at the edge of the shaft. So if it is rotating in this direction, so you can see in the clockwise direction. So, and if we assume that it is rotating as the smooth rotation, then what happens? So the center we have the line of action. So the center of gravity lies in its axis. So only we'll tell that the shaft is rotating smoothly. So when the shaft is rotating smoothly, that means the mass is evenly distributed, and it means the center of gravity lies on the line of or axis of rotation on the line. So if you are adding a mass m, so you can see if you are adding a mass along with the rotation of the shaft, then we say that the mass will not stay or it will not place in any direction. So for example, so if you rotate a wheel, the cycle wheel, if you rotate by keeping in its stand, so when if we rotate, always we see that the valve, that is air filling point, the valve point will be in the downward direction. So the wheel oscillates, and so that valve point, it goes to the lower point of the on the downward direction. So what does it mean? So the center of gravity is moved from the line of axis to some distance in the downward point. So that is the meaning of that condition. So before adding mass, what happens? The shaft rotates and the mass is evenly distributed. But when we add mass, it is only lying in the lower point of the shaft, and the shaft, and so it is unevenly distributed. So you can see that when the mass pulls the center of gravity to the downward direction. So because of this, what happens? The shaft begins to bend while rotating, and this causes vibration or noise in the during the rotation of the shaft.